You can use x plus 1 squared to help you find x plus 1 to the third. X plus 1 squared is x plus 1 times x plus 1. Like you got a FOIL. Well, 7 version. You can totally like work together. I have no problem with that. Pat, and what's x plus 1 the quantity squared? And that trinomial can get multiplied to x plus 1 for x plus 1 cubed. Thank you. X plus 1 cubed. Owen has x cubed plus 3x squared plus 3x plus 1. Okay. And if we take that times x plus 1 for x plus 1 to the 4th, looks like Nicholas has x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. Oh, those numbers. Grayson recognized them, did you? Dun, 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 dun. This is Pascal's triangle. Let's talk about what's super cool about Pascal's triangle. If we take two numbers from a row and add them, it's the number that is below. So 3 plus 3 is 6, 4 plus 6 is 10, 10 plus 10 is 20, 5 plus 1 is 6. We can keep going for a long time. Okay. So I want you to look at these numbers right here. And then I want you to look at the coefficients right here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. They're right there. Okay. Now, you don't have to memorize Pascal's triangle. Okay. I'm going to give you another trick here pretty soon. Okay. But Pascal's triangle does describe the coefficients of x plus y to the n. Okay. So we're going to use Pascal's triangle to help us. How annoying was it to take x plus 1 times x plus 1 times x plus 1 times x plus 1. Okay, if I ask you for x plus 1 to the 8th, it's really inefficient to do foiling 7 times. Okay, super annoying also. Okay, we can use the fact that Pascal's triangle is the coefficient for a binomial to the nth power to make this go a lot faster. Okay, so this is the binomial theorem. Okay. This is the binomial theorem. X plus y to the n power is the sum of the combination n choose r, x to the n minus r power, y to the r. We start at 0 and we keep plugging in for r until we get to n. Write it down and we'll make a little bit more sense of it soon. Right now, yes, it looks like gibberish. We'll make sense of it. Now, didn't I just tell you that Pascal's triangle was the coefficients? But here I have n choose r in there. Pascal's triangle is combinations. Okay, like this row right here, 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Okay, you don't have to memorize Pascal's triangle. Knowing how Pascal's triangle works is pretty cool. But if we just know that Pascal's triangle are combinations 0 through n for each row, we can use our calculator to help us and not memorize Pascal's triangle. Okay, so what's going to happen is that when we expand a binomial, okay, we are going to start with n, and that comes from right here. Okay, n combinations of 0, x to the n, y to the 0. And then our next term is going to be n combinations of 1, x to the 1 less power, r to the 1 more power. Okay, your powers are always going to add up to be this power right here. And what's going to happen as we go from left to right, this x power is going to decrease, this r power is going to increase until we get all the way to we have all of our terms. Okay, so I am going to show you what that looks like with 2x minus 3 to the 4th. Please write it down. I did not check it off as such. Okay, so here 2x is our first term. -3 would be our second term. Notice how we wrote the expansion for x plus y to the n. Okay, if it's subtraction, that negative needs to go in that second term. Okay, and our n is 4. So we are going to start with 4 combinations of 0. And we take our first term to that power and our second term to the 0 power. Okay. Then our next term, we are going to increase that combination by 1. So now it's 4 choose 1. Our first term is going to decrease a power and our second term is going to increase a power. Keep going. Then we have 4 combinations of 2. 2x is now to the second, -3 is now to the second. Another room here. Then we'll have 4 combinations of 3, 2x to the first power, -3 to the third power. And then our last term is going to be 4 combinations of 4. We know this is our last term because now these two, N and R, they match. We can't go any further. 2x is now to the 0 power and -3 is now to the 4th power. Okay, so notice in all 5 of those terms, our exponents add up to be 4, which is our N power. Also notice that in each of our terms, this number right here for the combination matches the power of the second term. Do you see that? How those match? That's going to be important later on. Okay. Now, I'm going to be a little bit obnoxious in how we solve for this. I realize that at this point, you can probably put everything into your calculator, but I want to make sure you understand where all these numbers come from. So let's start one term at a time. What is 4 combinations of 0? This is where you help me. Is 1. If you put it in your calculator, it's 1. Okay. Now, if we take 2x, the quantity to the 4th, yes, x gets to the 4th, but 2 also gets raised to the 4th also. What's 2 to the 4th? Okay. And anything to the power of 0 is 1. Okay. So our first term is 16x to the 4th. Our second term, we have 4 combinations of 1. If you put that into your calculator, we get 4. We have 2x, the quantity cubed. So that's going to give us 8x cubed. And -3 to the first power is a plain old -3. I do need your help. What is 4 times 8 times -3? So our second term is -96x cubed. Four combinations of 2 is 6. 2x, the quantity squared, gives us 4x squared. And then -3, the quantity squared, is going to give us a +9. This is what I've noticed about some of you in your calculators. You forget that a negative to a power needs to actually be included in parentheses. If you're going to put -3 to the second power in your calculator, first of all, I don't know why you would need to do that. But second of all, if you actually do it, -3 needs to be in parentheses to the second power to actually get the +9. If you put this into your calculator, it's going to give you -9 because it's squaring the 3, not the -3. Okay, what is 6 times 4 times 9? We have 216x squared for our next term. All right, next term, 4 combinations of 3. Gives us 4. 2x to the first gives us 2x. What about -3 cubed? -27. So what is 4 times 2 times -27? Ooh. And then our last term, 4 combinations of 4, 2x to the 0, and -3 to the 4th gives us a +81. We took a binomial to the fourth power and didn't even have to FOIL. I think that's pretty awesome. Now, the time that it took us up here, I don't know how much time we saved because we had to talk through everything. And yes, you're going to have to put some things in your calculator. However, I feel like the room for error in this compared to FOILing 3 times is quite a bit different, okay? I think it's a lot easier to make a mistake when you're multiplying binomials together than it is when you're setting this up. Okay, as long as you understand the process. Okay, it's going to save us time. It's going to save us from making little mistakes. Okay, especially if you're not very organized with your distributing. It's pretty easy to miss a multiplication, miss a sign, miss add. Okay, now this right here, you wouldn't necessarily have to show me, okay? You could go from here to here and I'd be fine. However, especially so that I can understand that you understand, I do at the very least need to see the setup with your answer. I can't just have an answer. I know you're going to do a lot of work in your calculator, but I do need to see the setup, okay? So let's try another one. Go ahead and write this one down. X squared plus 4, the quantity cubed. Okay. Well, this one's pretty nice because it's only to the 3rd power. But we do have something a little different going on. We have x squared as our first term. That's fine. We're just going to do everything the same. So when we set this up, we're going to have 3 combinations of 0. Our first term cubed, our second term to the 0. Now we're going to increase our combinations and the power of our second term while we decrease the power of our first term. So now we have 3 combinations of 1, x squared squared. But now 4 to the 1. Remember, we always want this number right here to match this exponent right here. Those are always going to match. Okay. And we'll have 3 combinations of 2, x squared to the first, 4 to the second, and 3 combinations of 3. I know this is the last one because we've reached where n and r are the same number. X squared is to the 0, 4 is cubed. So this is fine. Okay. Remind me, what do we do with a power to a power? We multiply. So this is going to be something x to the 6th. Go ahead and find me each of these 4 terms. When you get to the 4 terms, compare them with a neighbor. Grayson, what's our first term? Katie, what's our second term? Paige, our third term. 38. 48 x squared. And then our fourth term, what'd you get? What? This should be to the fourth?
No. On the
This one? Okay, are we good? Okay. Okay. And then our last term is? Okay. Did you have to put forth a lot of effort to get those 4 terms? A lot of effort. Max out your brain. Okay, now a plus 2b to the 8th. I'm not going to give you something to the 8th power and make you find all 9 terms. But I could ask you for one individual term. So go ahead and write this down, and we're going to talk about the 6th term. And I want you to discuss, don't write anything down, just talk about with your pod what you think that term needs to start with. Which combination do we start with to set up our term? Ready, set, talk about it. For the 6th term. We only want the 6th term. Okay, so I should, since this is the 6th term, start out with 8 choose 6, right? Why not, Bella? Okay, our first term is 8 choose 0. Our second term is 8 choose 1. Our third term is 8 choose 2. So by the time we get to our 6th term, it's 8 choose 5. Okay. Now, what did I tell you? Which one gets the exponent of 5, A or 2B? 2B gets the exponent of 5, which means A gets the exponent of, how'd you get that, Isaac? They need to equal this n. Okay. So in your calculator, you're probably gonna need to do 8 choose 5 times 2 to the 5th. Probably not gonna do that in your head. So we have a calculator. No. Do you know where the choose and 3? Hey, can't you find this number?
No.
No, you're just letting everybody else work for you. Kind of. Okay, so what is 8 choose 5 times 2 to the 5th power? Nicolette, did you get that? Okay.
It's 1,792 plus
Like that? 1 1,792, is that what you got?
Yeah.
Cool. How she got that answer? So A combinations of 5, okay, times 2 to the 5th. Okay. Okay, I want you to, at your pod, write down 3a minus 2b to the 11th. And I'm concerned about the coefficient of a to the 6th, b to the 5th. Set up which term you think we're talking about. Okay, so it's 11 combinations of something. 3a and negative 2b are the two terms in our binomial. We want a to be to the 6th power, and we want b to the 5th power, right? So this is 11 combinations of 5. So in your calculator, you need to do 11 combinations of 5 times 3 to the 6th times negative 2 to the 5th. It's going to be a negative number, we know that. What? Oh. Yeah. Okay, so technically the term would be this a to the 6th, b to the 5th, but I asked for the coefficient. So the coefficient is just that number. What? If I ask for the coefficient, I want just the number. If I ask for a coefficient, I need you to understand that that's just a number. Okay. Guess what? We have 10 minutes where you can get started on this homework. Go West! We still need our books, so just kidding. But it's our last like normal homework assignment of the semester. What's your first problem?
The first.
What number?